Will buffer be automatically flushed to disk when a process exits? When I redirect a command's output to a file, for example, echo hello and gt file, will that file be guaranteed to have such data right after the command exits? Or is there still a very small window between the command exits and data written to the file? I'd like to read the file right after the command exits, but I do not want to read an empty file.
There are multiple layers of buffers/caches involved. The CPU cache. The data is put together byte by byte, and stored in the CPU cache. If the CPU cache is full and the data has not been accessed for a while, the block containing our data may get written to main memory. These are, for the most part, hidden from the application programmers. The in-process buffers. There is some memory set aside in the process where the data is collected, so we need to make as few requests to the OS as possible, because that is comparatively expensive. The process copies the data to these buffers, which again may be backed by CPU caches, so there is no guarantee that the data is copied to main memory. The application needs to explicitly flush these buffers, for example using fclose3 or fsync3. The exit3 function also does this before the process is terminated, while the _exit2 function does not, which is why there is a big warning in the manual page for that function to call it only if you know what you are doing. The kernel buffers. The OS then keeps its own cache, to minimize the number of requests it needs to send to the disks. This cache belongs to no process in particular, so data in there may belong to processes that have finished already, and since all accesses go through here, the next program will see the data if it has reached here. The kernel will write this data to the disks when it has time to do so or when explicitly asked. The drive cache. The disk drives themselves also keep a cache to speed up accesses. These are written fairly quickly, and there is a command to write the remaining data in the caches and report when that is complete, which the OS uses on shutdown to make sure no data is left unwritten before powering down. For your application, it is sufficient for the data to be registered in the kernel buffers. The actual data may still live in CPU caches at this point, and might not have been written to main memory. The echo process terminates, which means that any in-process buffers must have been flushed and the data handed over to the OS, and when you start a new process then, it is guaranteed that the OS will give the same data back when asked.
If the application doesn't have any internal caches, then the changes will be immediately written to the file. The same for your example. The file is a logical entity in memory which will be immediately updated. Any subsequent operations on the file will see the changes made by the program. However, this does not mean the change was written to the physical disk. The changes might linger in the OS file system caches or hardware caches. To flush the file system buffers, use the sync command. I'd like to read the file right after the command exits, but I do not want to read an empty file. You shouldn't run into any practical problems here.
Will buffer be automatically flushed to disk when a process exits? In general, the answer is no. It depends on the command. As the other answers mention, if the command does not internally buffer the data, all data will be available when the command terminates. But most, if not all, standard I/O libraries do buffer stout by default. to some extent, and give different guarantees about the automatic flushing of buffers when the application closes. C guarantees that a normal exit will flush the buffers. Normal exit and NBSP means that exit is called, either explicitly or by returning from main. However, abnormal exit can circumvent this call and therefore leave unflushed buffers behind. Here's a simple example. If you compile this and execute it, test will not necessarily be written to step. Other programming languages give even fewer guarantees. Java, for instance, does not auto-flush upon program termination. If the output buffer contains an unterminated line, it may therefore be lost, unless system.out.flush was called explicitly. That said, your question body asks something slightly different. If the data arrives in the file at all, it should do so immediately after the command terminates, subject to the caveats described in the other answers.
I think that no question addresses this issue sufficiently yet. I'd like to read the file right after the command exits, but I do not want to read an empty file. As the other answers explain, a well-behaving program flushes its internal file buffers before the process terminates normally. Afterwards, the data may still linger in kernel or hardware buffers before it's written to persistent storage. However, the file system semantics of Linux guarantee that all processes see the content of files in the same way as the kernel does, including internal buffers 1. This is typically implemented by having at most one in kernel buffer per file object and to require all file access to go through this buffer. If a process reads a file, the kernel will present the buffer content to the process, if the requested file part is currently in the buffer. If it is not, the kernel will fetch the data from the underlying storage medium and place it inside the buffer, then go back to the previous step. If a process writes to a file, the data is first placed inside the in-kernel buffer for that file. Eventually, the buffer content will be flushed to storage. In the meantime, read access is satisfied from the same buffer, see above. One at least for regular files, directories and symbolic links. The thos and sockets are a different matter since their content is never stored persistently anyway. There are some special cases of regular files whose contents depend on who's asking. Examples are files in procs and sysvs, think/proc/self, which is a symbolic link to the process if the process reading the symbolic link.
If you want to watch reasons of a society